So last session we were discussing about how to write the molecular formula. I told you should study the periodic table. So just you have to study the group wise, group 1, 2, then there is no 3, 13, 14, 15, 16, 17, 18. Why I kept group 13? Because in between group 2 and group 13 there are 10 other groups that you don't want to study. You just study only this many, but this one please study the elements. So here in this group 1 we are writing hydrogen also, but hydrogen is not exactly in the group 1 that we will discuss in the other lesson, but I am putting hydrogen also here. So hydrogen, the next element will be lithium, then sodium, then potassium, then rubidium, cesium and francium. These are the elements in group 1. So you can connect this, the group number is equal to the number of valence electrons. Group number is equal to number of valence electrons. So here the group 1 means all these elements are having 1 electron in the valence shell, outermost shell. If there is 1 electron in the outermost shell, these elements are always having a tendency to attain stability by removing that 1 electron. So it can remove 1 electron and become stable configuration, because the stability we can say either it should lose the electron and become empty orbital, or it should gain the electron and become 8 electrons, octet rule. Last year you studied about octet rule. So here either it should lose this 1 electron and become empty, or it should gain 7 electrons and become octet. So it is easier. Actually atoms are like us. We need always the shortcuts or easy methods or easy ways. The same thing, hydrogen also lazy element. So these group elements also lazy ones. So they also try to lose the 1 electron and attain stability rather than gaining 7 electron and become 8. So here it will be trying to lose the electron, and so the valency is +1. And in group 2 the elements are here beryllium, magnesium, calcium, strontium, barium and radium. Here these elements are in group 2. As it is in group 2, the number of valence electrons also 2. As it is having 2 electrons in the valence shell, either they will try to lose these 2 electrons to become empty or stable, or else to gain 6 electrons and become octet. So which is more easier? Losing that 2 electron is easier. So that losing, it will be losing the electron means it attains positive charge +2. Then in between group 2 and group 13 there are 10 more groups that we will be discussing later in the periodic classification of elements. So here we can write group 13 elements. Group 13 elements starting with boron, aluminium, gallium, indium and thallium. So as these are the group elements, see from group 13 onwards the number of valence electron is equal to group number -10, because there are 10 other groups in between I told you. So you can remove, subtract 10 from this. So 13 minus 10 will be 3. So the group number is equal to 3. So as the group number is 3, either it should lose these 3 electrons to become stable, or it try to gain 5 more electrons to become stable. So losing is more easier. So it will be losing 3 electrons and valence is +3. Then coming to which one? We have group 14. Group 14 elements are carbon, silicon, germanium, tin, lead. These elements having 4 electrons in the valence shell, because group number is 14, 14 minus 10 will be 4. So there are 4 electrons in the valence shell. As it is having 4 electrons, either it should lose 4 electrons or it should gain 4 electrons. So losing 4 and gaining 4 will be equal possibilities. So it will be showing a valency of +or -4. Now coming to which one, we can say the group 15 elements. They are nitrogen, phosphorus,, arsenic, antimony, bismuth. They are having 5 electrons in the valence shell. As there are 5 electrons, either it should lose 5 electrons or it should gain 3 more electrons, become octet. So losing 5 is a difficult task. So easy task only they will be choosing. So they will be trying to gain 3 electrons. Gaining 3 electrons means gaining 3 negative charges. So as it is gaining 3 negative charges, its valency will be -3. Then group 16 will be oxygen, sulfur, selenium, tellurium and polonium. These elements are having 6 electrons in the valence shell because group number is 16, 16 minus 10, 6. So valence electron will be 6. So either it should lose 6 electron or gain 2. So gaining 2 is easier. So -2 is the valency. Then group 17 is fluorine, chlorine, bromine, iodine and astatine. So they have 7 electrons in the valence shell and so its valency will be -1. And group 18 there will be, group 18 elements there will be helium and neon, argon, krypton, xenon and radon. They have 8 electrons in the outermost shell and valency will be 0. So these are the major elements, and before I discussed from the periodic table only these elements are existing in the molecular form. That means here the elements are hydrogen in the diatomic form, nitrogen will be in the diatomic form, oxygen is in the diatomic form, fluorine, chlorine, bromine, iodine, these are in the diatomic form. Then here we know phosphorus is in the tetraatomic and sulfur is in the octatomic form. The remaining all elements, when you are writing the molecular formula or balancing a chemical equation, their symbols will be atomic form only you should represent, but these elements you should write in the molecular form. So if you know this many and some of the polyatomic ions which are known as radicals and their valencies, then it is easy for you to write the molecular formula. So I will be writing the radicals or polyatomic ions. What do you mean by radicals or polyatomic ions? That means they are group of elements. This group of elements, they will possess, together they will possess a single valency. They are collectively known as radicals or polyatomic ions. Polyatomic means many atoms together, they will possess a single valency. That also we should remember. So let us consider the first one is hydroxide. Hydroxide can be represented as OH negative, that means valency 1. Then here O and H are two atoms, together they will possess a single valency of -1. Then ammonium ion, which is having a symbol of NH4 with a +1 charge. Then bicarbonate or hydrogen carbonate. It is having HCO3 -1. Then nitrate NO3 -1. All these are having 1 is the valency. Here there is a difference, only ammonium is having +1, the remaining all are having -1 valency. Then we can write carbonate. Carbonate is CO3 2 negative. Then sulfate SO4 2 negative, then sulfite SO3 2 negative, then phosphate is PO4 3 negative, these are the major required radicals or polyatomic ions you should remember: hydroxide, bicarbonate, nitrate, then ammonium, carbonate, sulfate, sulfite, phosphate, etc. These are the major ones that you should remember in the case of radicals. More than this, so many polyatomic ions are there, but even though these you should remember, in grade 10 it is required for you. Then here there are certain atoms I will tell you. I told you that there are certain elements which are present in between group 2 and group 13. There are 10 group elements are there. And these elements will be showing variable oxidation state, variable valencies. Variable valencies means in a particular compound they will be showing a particular valency, in another compound they will be showing another valency. That we will be discussing, or I will give you in the case of iron. Iron main elements only I am giving you. Iron can exist in two oxidation state. One is Fe2 positive, another one is Fe3 positive. Fe2 positive is known as ferrous and Fe3 positive is known as ferric. Then second one is copper. Copper also can exist in two valencies, that is +1 and +2. +1 is known as cuprous, +2 is cupric. There are so many other elements: cadmium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, etc., etc. Out of that, these are the major. Zinc also you should remember. Zinc, there is we are having only one valency, that is Zn2 positive. Why I am giving? Because we need this zinc in most of the chemical reactions. Then these are the major elements and the radicals we need to remember when we are writing the molecular formula of each and every compound. If we know these many things, we will be able to write the skeletal equation first, then we will be able to write the balanced equation also. I hope you understood whatever is required for studying this lesson. These are the basic requirements we should know to write the molecular formula of the compounds. So this is about the periodic table, then polyatomic ions, the elements and their valencies.